In this video, we're going to study measuring angles in both degrees and radians. So this is one of the very important topic if you plan to study trigonometry or pre-calculus. Um, so we use several units to measure angles. So we use several units. We use several units to measure angles. So most common ones are, the first one is the degree. That's the most common one. And then we have radians. So that's what we normally call the universal unit, radian. And then we also have revolutions. So that's normally used in industry. So called the revolutions. Or sometimes we call turns. So it's the same thing, turns. So we can call it turns. And then there was an attempt to use the powers of 10 to measure angles, like metric system. So that's what we call the a gradient, or called the gradient. Not radian, but called gradient. Or sometimes we even call this is like gons. So use the unit G. So use the letter G for that. So these are the most common ones, but in this discussion we're gonna focus on the first three. Um, so what is an angle? So angle has three properties. So if you draw an angle, so we can consider three properties. So what are the three properties? So these are like straight lines, and then we have the vertex. So this is the vertex. So it's gonna turn around that point. So we call the vertex. Vertex, and then there's the initial side. Initial side, and that's where you're gonna start measuring angle. So the angle gonna go like that, and then we have the terminal side. That's where the angle gonna stop. So terminal side. So the three things: initial side, and it's going to turn around the vertex and the terminal side. And then there are positive and negative angles. So positive versus negative angles. Negative angles. So if you measure an angle counterclockwise, we call that is a positive angle. So so that's the initial side. So you measure an angle like that. So angle gonna go counterclockwise. So we call this is a positive angle. So positive angle, positive angle. So this is gonna go counterclockwise. Clockwise. So you can call it counterclockwise, CCW. Or the other angle is gonna go negative angle. So let's say, for example, initial side, but this is the angle, but we're gonna measure like this. We're gonna go backward. So that's the angle. So it's gonna go clockwise. So we call this a negative angle. So this is a negative angle. Negative angle. So negative angle. So it's gonna go. This is gonna go clockwise. So if you measure the angle clockwise, we call it is a negative angle. If you go counterclockwise, we call it is a positive angle. Then the next important topic is, like, you always have a question where you start with. So if you start with on the positive x-axis, you call the angle is in the standard position. Standard position. Standard position. Standard position means you measure the angle starting from the positive x-axis. So we can talk about the two cases. So let's say you're going to start measuring the angle on the positive x-axis. That's the initial side. So then let's say the terminal side is this one. So that's the angle. So we call this is the angle is in the standard position. So alpha is in standard position. So this is the terminal side. And the initial side is on the positive x-axis, no change. So this angle is in positive standard position, but this angle is a positive angle. And similarly, you can have a negative angle, again start on the positive x-axis, and then so this is the angle. So you can measure the angle clockwise direction. So I'm going to call this angle is beta. So beta is a negative angle because you measure clockwise. So again, this is the initial side, and this is the terminal side. So those are the only two types. So positive angles and negative angles. So the next one is the quadrants. So there are 4 quadrants. Quadrant means 4. So there are 4 quadrants. Quadrants. There are 4 quadrants. So we're going to divide the xy plane into 4 parts by the xy axis. So this is the x-axis and the y-axis. And then we're going to start counting quadrants. So this is the quadrant 1. Quadrant 1. So we use the Roman letters for that. And then the quadrant 2. And then quadrant 3. And then the quadrant 4. Sometimes we just use the Roman letters. We don't write the quad here. So those are the 4 quadrants. These are very important later. So let's look at several angles in several different quadrants. So for example, so angles in different quadrants. Different quadrants. So for example, so this is an angle in the second quadrant. So we always use the same initial axis or initial side. So this is the angle. So this angle is in the second quadrant. So I'm going to call this is theta 1. So theta 1 is a positive angle which is in quadrant 2. And let's look at an angle which is in the third quadrant. So the angle, the initial side, terminal side. So that's the angle. So theta 2, I'm going to call this angle as theta 2, which is a negative angle, and it is in the third quadrant. And then, so let's look at an angle in the fourth quadrant. So this is the angle. This is how we start. So we're going to go one cycle and another cycle and go like that. So this is more than 360 degrees. So I'm going to call this angle is theta 3, and you can see theta 3 is a positive angle and it is in the quadrant 4. Good. So if the terminal side is lies on the x or y axis, we call this angle is a quadrantal angle. So let's say if the terminal side, lies on the x-axis or y-axis, x or y-axis, the angle is called quadrantal angle. Quadrantal angle. Those are special kind of angles. The terminal side is on the x or y axis. So let's look at two cases. So this is one such angle. So it's going to start here and end there. That means the angle looks like that. And another case, maybe uh, an angle like this. So let's say it's going to go one complete cycle. So start here. It's going to one complete cycle by its negative and go one complete cycle. So this is a quadrantal angle again. So it's going to go one complete cycle like that. It's a negative angle. This is a positive angle. This is a negative angle, but they are both quadrantal angles. Because see, the terminal side is on the x-axis and the other one is terminal side is on the y-axis. So now let's talk about the degree measure. The degree measure is believed to be related to the number of days in a year. So it's like 365, it's closely related to 360. And also in mathematically, 360 is a really nice number which has 24 different devices or 24 different factors you can write. So there are so many factors, so it can make it very easy in mathematics when you simplify. Um, so we say an angle of one revolution. So this is angle of one revolution, angle of one revolution or one cycle. Angle of one revolution is, we consider it as 360. So we take it to be like that, 360. So one cycle is 360. So that's where all the math can start. Now we can use that idea to talk about the rest. So for example, so we have one line. So we can talk about one full cycle. So we can start there and go one full cycle, and we can call it, there are 360 degrees here. So that's a kind of definition. And then we can talk about half cycle. This is like a full cycle. Now we can talk about half a cycle. So the half a cycle is like this. So you go only halfway. So this also we call straight angle. So we can call this is a straight angle. So you can start here and go like half a cycle. So in degrees, since the full cycle is 360, so we have only 180, half of that. And then we call this is a straight angle. Straight angle. It's very easy to see why we call it. And then there are some other special angles also, like for example, if you have an angle like this is like special situation, we call this is 90 degree, and then we call this is a right angle, right angle. And then you can also have right angle like backward, like negative angle. So let's say this is the angle, but you can have like a positive angle like that. So this is like 270. So if you go like that, so it's a 270. And then we also have a different name for that. So this is the terminal side here, and the terminal side is there. So if you measure an angle like that, it's like more than 180. So we normally call this a reflected angle. Reflected angle. Reflected angle. So we have straight angle, right angle, reflected angles. There are several other common angles. So what we call the acute angle, right angle, and obtuse angle. So if an angle is like that or less than 90, so that's the angle. So we call this kind of angle is a acute angle. Acute angle less than 90 degrees. And then we have this special situation. This is what we call the perpendicular. Doesn't look like perpendicular. So it's exact 90. So we call the right angle. And then there are angles which are more than 90 degree. It's like this. So this is the angle. So we call this angle is obtuse angle. Obtuse. Obtuse angle. So those are three types. So this is 90 degree. So if you call this theta, so it is in between 0 and 90 degrees. this is exactly 90 degrees, and this is a more than 90. So it is like a more than 90 degree and then less than 180. So that's what we call obtuse angle. So let's look at some examples. Let's do draw each angle. So let's say draw each angle. So let's start with these four. So let's draw 45 degrees and then negative 90 degrees and then 240 degrees and then 405 degrees. Okay, so let's start with the first one. So 45 is a half of 90, so that means it's going to go exactly in between. So this is a 45 degree. So it's a 45 degree angle in the standard position. So that's the initial side. Sometimes you even don't draw that. And the next one is negative 90. That means it's going to go clockwise. So these are the axis. So it's going to go backward. So that's the angle we are talking about. This is negative 90. Initial side and the terminal side. And then we have 240. So what is 240? You can see 240 is more than 180 and less than 270. So that means it should be in the third quadrant. So this is like this. So it's more than 180 and less than 270. So it's like 60 more than 140. So that means it should be like that. So that's the angle, the terminal side. So this is 240. And it's also positive, which is in the third quadrant. This one is a quadrantal angle, negative 90. First one is the first quadrant. Okay. So let's look at 405. 405, you can kind of write this as 360 degrees plus 45. What does that mean? It's going to do complete one cycle and go extra 45. That means it's going to go to the first quadrant. So if you draw it, so the terminal side exactly going to be in between like that. But how you draw the angle? So what we can do, we can start from the initial side. It's going to go one cycle and go extra 45. So that's how you write it. So complete cycle and go a little bit more. So this is a 405 degree 405. Good. Next, let's talk about coterminal angles. Coterminal angles. Coterminal angles. Coterminal angles means the if the terminal side is the same, we call those are coterminal angles. So angles that have the same initial and terminal side. Since we talking about the standard position, everyone has the same initial side, which is the positive x-axis. So we need to worry about the terminal side. So let's say angles that have are the same initial and terminal side. Same initial and terminal sides. So we actually need to worry about the terminal side because we have the exact same initial side, because the angles we talk about are in standard position. So let's look at one situation. So let's look at this situation. So let's say we have these two angles. So one is 120. So we have this angle. This is 120. And then you can have another angle, negative angle, that's going backward. like this angle. So the question is how much is that? And you can see that this is 30 degrees here. So that means this has to be 60 degrees. Um, that means it should be 180 plus 60. So that means this is negative 240. Negative because it's going in the clockwise direction. Okay, so and then you can see that 120 and negative 240 are coterminal because they have the same terminal side. They have the same terminal side. Um, so why these are important? So if the angles are coterminal, in the future we know that they have the exact same trigonometric function values. So the coterminal angles have the same trigonometric function value, have the same trigonometric function values. Trigonometric function values. For example, you're going to learn that. So as an example, you're going to learn that sine, like let's say sine 120 is exactly equals to sine of negative 240 because they are the exact same terminal side. So you can see that they are exactly the same, but you don't know right now, but you will learn that they are exactly the same. So what it says that the coterminal angles have the same trigonometric values. Okay, so let's look at one more example. So what it says, find one positive and one negative angles that are coterminal to 225. So if you draw this angle, and you can see that it is on the because more than 180 less than 270, it has to be on the third quadrant. So that's the angle looks like. So this is 225, and then so what we want to find is a angle which is coterminal to that. So we already know that this angle, if you go backward, so which is, and you can see this is a negative 135. So the reason is you can see this is 45. So to get the other angle, you have to subtract 45 from 180. That's how you get negative 135. Negative means because it's going backward. So what we're trying to do is we try to find one positive and one negative angle that's a coterminal to 225. So the easiest way to do that is you add one extra cycle. If you add a cycle or you subtract a cycle, you get coterminal angles. So that means if you start with 225 and add one complete cycle, that means you add 360. So when you add that, the new angle is coterminal to the original angle because you go just one cycle, that means it should end up with the exact same place. So that's the idea. And the same thing you can subtract. That's one way to get it. The other way is you start with this and subtract multiples of 360. So when you do that, and you can see when you subtract these two, you get negative 135. That's how you get the negative angle. So in theory, so let's try this as a note. So what are you gonna do? You add or subtract multiples of 360. So you can see coterminal angles uh, can be generated by adding or subtracting multiples of 360, multiples of 360 degrees. So that means as a formula we can write this like this. So if your original angle is theta, you're going to do 360 times n, where n is a integer, where n is an integer. So that's how you can find integers, like we know that plus or minus 1 or 0. 0 plus or minus 1 plus or minus 2, like that. Those are what we call integers, positive and negative integers. So if you add multiples of 360, okay, if an integer is negative, you're going to subtract. If an integer is positive, you're going to add. So you just add multiples of 360, you get all the coterminal angles. This will be very useful later. Next, we have complementary and supplementary angles. So complementary and supplementary angles. So if the sum of two angles is 90 degrees, so like let's say you have two angles, the sum of the two, so this is, let's say, angle alpha, angle beta, this angle alpha, this angle alpha and beta. So if the sum is 90 degrees, we call these angles are complementary. So positive angles alpha and beta, positive angles alpha and beta are complementary if the sum of the two, alpha plus beta, equal 90 degrees. So then what happened in this case, you can say one angle you can get it from subtracting the other from 90. So that's what useful later. So we can use these ideas later. Okay. See, other type is so this is called complementary. Supplementary means you're gonna you have two angles. So sum of the two angles is 180. So the one angle alpha, that's one angle, and the angle beta is the other angle. Now you see the sum of the two is 180 degrees. So alpha, or you can call it like a different letter if you want. So let's call it gamma and delta. So gamma and the delta. So if the sum of the two, gamma plus delta, equal 180. Okay, when you have variables, you do not put any units for that, because the variable carries a unit. So we don't say alpha degrees, we don't say that, just alpha. And the next one is again positive angles. Delta and gamma are supplementary if the sum of the two, so delta plus gamma equal 180. So then what happened in this case, again as before, let's say you want to take gamma, which is 180 minus delta. So you can write expressions like that if the angles are supplementary. So next, talk about how to convert angles. So we can talk about how to convert a angle which is written in decimal notation to the degree, minute and second version. So degree decimal versus the degree and the minute and second version. So we sometimes we call this is a DMS. So degree and the minute we use like 1 prime, and second we use double prime. So DMS form. So degree decimal versus the degree, minute and second version. So 1 minute, we can write this as 1, like with a prime. This is 1/60th of a degree. So you cut a degree into 60 equal parts, and then you call it as a 1 minute. And then because of this one, you can say 60 minute equal 1 degree. And then 1 second. So what we can do, we can divide a minute into 60 parts. We call that as a 1 second. So 1 second is equals to, the notation is 1 double prime. This is 1/60th. You divide a minute into 60 parts. So you get 1 second. When you divide 1 degree into 60 parts, you get 1 minute. When you divide 1 minute into 60 parts, you get a second. So this says that 60 second equal 1 minute. Good. And then also we can write some other relations here as well. This also tells that 3600 minute seconds equal 1 degree. We can see why. So we can write this relation like this. So we can see that 1 second equal 1/60th of a minute, and then we know that 1 minute equal 1/60th of a degree. So we can write it like this: 1/60th, and then another 1/60th. You divide that because 1 minute equal 1/60th of degree. So we can say there are this many degrees. So in other words, 3600 minutes. So that's where it's coming from. So these all are useful in simplifications. Just put everything in as result. So we say 1 uh, minute equal 1/60th of a degree, and then 1 second equal 1/60th of a minute, or 3600th of a degree. So these are all useful when solving problems. So let's just do one conversion problem from each, back and forth. So let's do this problem. Okay, we can say and separate them. So let's look at this problem. So the problem says convert 51 degrees, 6 minutes and 21 seconds to a decimal degree form. So what we're gonna do, we're gonna start with this and we're gonna split them into different types. So we say 51 degrees, 6 minutes, 21 seconds. We're gonna split this. So you can say it is 51 degrees plus 6 minutes plus 21 seconds. Now what we can do, since we know each factor, we're going to substitute from degrees. So it is 51, so it's already degrees, so we leave it. But we know that this is 1 minute is 1/60th degree. And then do the same thing. We know that 21 times, we know that this is 1/60th of a 1/60th of a degree. So we can write it like that, and then what we can do, we're gonna you can use a calculator and simplify these. And once you do that, you're gonna get 51 degrees plus, you can see 6 get cancelled, so it's 1/10. That means 0.1 degrees. And then again use a calculator, you will get 0.0058 degrees. Since they are all degrees now, we can just add them. So it is 51, and you have to look for the proper decimal place. So 1 point is like 51.1058 degrees. So you can see this is only in decimal notation. This is what we call the degree decimal form. So let's look at a problem. We're going to convert that into, starting with the degree decimal, go backward to DMS form. So let's do that now. So we have convert 37.413 degrees to DMS. You can see we have a decimal form, but we can turn to a degree minute second form and round to nearest second. So the problem is also very similar. What we're gonna do again, so we can start with 37.413 degrees. You can split the degree part, so 37 degrees plus 0.413 degrees. Now what we're going to do, we're going to first find the minute, but we know that 1 degree equals 60 minutes, so we're going to replace the degrees by a minute first. That's the first thing. So let's try this one like this. 37 degrees plus 0.413 times 60 minute. The reason is we know that 1 degree equals 60 minutes. So we replace 1 degree by 60 minutes because 1 degree equals 60 minutes. So now we just gonna multiply these two. So let's say what we get. So 37 plus, when you multiply, you're gonna get 24.78 minute. So now what we can do, we can take the integer part out. So there are that many minutes, and then take the fraction part and multiply by 60 again to get the number of seconds. So it is 37 and then 24 minutes, and then you're going to say plus 0.78 minute, and then you're going to replace the minute by 60 seconds. So it's 24 degrees 24 minute plus 0.78 times again 60 seconds. The reason is 1 minute equals 60 seconds. So each one is 60 of them. So multiply by that. And again, when you use a calculator, you will get 37 degrees 24 minute, and then here you're going to get 40. So let's write this one. So you're going to get 46 point, if you round it to, yeah, you get 46.8 seconds, but when you round it, it becomes 47. So if you round it, you get 37, 24 24 minute and 47 seconds. So that's how you do the conversion. It's a little long, but it's not that difficult. So what you do, when you get a fraction, you're going to replace that by the next one. That's how we do every time. When you get a fraction, you replace it by the next one. So this is a minute and this is seconds. Good. And then you can try these two as exercise. So the first problem is convert 103.247 to a DMS form, and the part B, convert 43 degrees 7 minute and 24 seconds to a decimal form. So you can find the answers in the description. You can try these two. Okay, so this is about the degrees. So let's talk about the radian next.